Welcome to Review Recording 1A-B for Section 6.4 of Unit 6, Chapter 6 in Math 2200. This recording goes along with instructional recordings 1A and 1B for Section 6.4. We'll be using lowest common denominators to simplify and solve rational equations, and we'll be solving problems involving rational equations. In this first example, we're asked which equation could be used to solve the problem below. A boat travels downstream and back to where it began, a total of 8 kilometers. The average speed of the current is 3 kilometers per hour, and the trip is completed in 2.5 hours. Find the speed v in kilometers per hour of the boat in still water. So we have two parts of the trip, downstream and upstream. The distance going downstream, it's a total of 8 kilometers for the trip, both down and up, so it must be 4 for each one. 4 kilometers. The speed of the current is 3 kilometers per hour. The speed of the boat in still water is v, so when we're going down the river, the current is helping us. And when we're going upriver, the current is against us, so it's subtracting from the speed. Time equals our distance divided by the speed. So the time going downriver would be 4 over v plus 3. The speed going upriver will be the distance 4 over the speed v minus 3. So we can rule out option C and D here. Looks like we can even rule out option B. But let's get the full equation anyway. So our time downriver plus our time upriver is equal to the total time of 2.5. That means we've got 4 over v plus 3, because that's the time downriver, plus the time upriver, 4 over v minus 3, and 2.5 is equal to 5 over 2. A is correct. In this problem, we have the concept of sharing going on. A school team collected the same amount from each student going on a trip. When 6 students could not go, each of the remaining students was charged an extra $3. If the total cost was $540, how many students went on the trip? Put in that little question mark that should have been there. So we have two groups of students to consider. There was the original group. Put that in this chart, and the group that actually went. Now, in the original group and the group that actually went, there were different numbers of students. In the group that went, we're looking for that. We'll call that X. And in the original group, therefore, they had 6 extra students, so there would be X plus 6 in that group. You could switch this around and say X was in the original group, then X minus 6 was in the group that went. But remember, it's X minus 6 is what you'd have to find then. Now, we need the cost per student. That is equal to the total cost divided by the number of students. The total cost in this problem was $540 for the trip. The number of students in the original group, though, was X plus 6. They were paying less per student because there were more of them. In the group that actually went, though, they had to be charged extra money, so their shares were calculated as 540 divided by X, whatever X turns out to be. They paid more per share in this case. So we need the greater share subtract the lesser share. That will give us the difference of $3, because each student was charged an extra $3 after 6 people bowed out. So our equation is 540 over X, because that's the greater share, subtract 540 over X plus 6, which equals $3 in the difference. We have non-permissible values of 0 and -6, which don't make sense for the problem anyway. The LCD is x outside of x plus 6. Now, of the two methods that I use in the instructional recording, I will choose to use the one where I multiply each of the terms in the equation by the LCD, like so. Therefore, x goes into x here once, and I've got 540 x plus 3,240 when I distribute that 540. Here, my x plus 6's will divide off, and I have minus 540x. Well, that's kind of nice because these two terms cancel out. And over here, I've got 3x squared when I distribute plus 18x. Carrying that last step over to a new screen, I've got 0 equals 3x squared plus 18x. Bring the 3,240 over to subtract it. All those terms are nicely divisible by 3 to get x squared plus 6x minus 1,080 equals 0. Now, 1,080 is fairly high, but it does factor, the expression does factor as x plus 36, x minus 30. It's a situation where you may have chosen to use the quadratic formula. So we've got x equals negative 36 or x equals 30. This one is inadmissible for the problem because the number of students cannot be negative. So therefore, 30 students went on the trip. In conclusion, when solving problems, it is often helpful to use a table. To solve a rational equation, factor your denominators, identify your LCD, find non-permissible values. Choose one of the two methods presented in the instructional recording, multiplying all the terms by the lowest common denominator or writing all expressions using the LCD and then comparing numerators. Then you solve the resulting equation and check solutions against non-permissible values to see if there are any extraneous roots. And of course, in a problem situation, you have to check for inadmissible values.